Okay, good day everyone. How are you doing? Okay, so trust your day went well. If you are coming across this video for the first time, please do well to like, share, follow, so that we can be notified when another one is released. So I am Tutor Glycol. Okay, you can just call me Tutor Glycol or just call me Glycol, anyone that didn't fit you. So in this class, we're going to be looking at simple harmonic motion. Actually, this topic is actually a kind of broad topic which students find confusing and distracting. But the thing is, I divided this video. This video is going to be in two parts, part 1 and part 2. The part 1 is the one you're actually seeing now, where we are covering all of these things in this objective. We're going to be looking at what is simple harmonic motion, what actually is simple harmonic motion. We're going to be looking at examples of simple harmonic motion, common examples that around you, and you understand. We're also going to be explaining simple harmonic motion in a straight line and in a circular path. Don't be afraid, there's nothing really different, just that some textbook, the way they put it, students find it confusing, but I'm going to be explaining that during the course of the video. We're also going to be looking at some important, let me not even say some important terminologies of SHM, because you see, the backbone or the real deal in this SHM or simple harmonic motion is actually the terminologies. See, where question comes out from, or where student finds confusing, is the terminologies. The moment you don't understand the terminologies, how they go, how the formula is derived, how they are solved, you will always feel question, because if you see any question is on the terminologies. It is very rare you will see a question and if they want to even ask you a theoretical question, okay, which of the following is true about SHM, simple harmonic, that's the commonest one they ask, but most calculative questions are always from the terminology. So it is very important that you stay to the end of this video to understand this thing, how they are derived, and if you actually have issue with it, please make sure you stay to the end of the video. And we're also going to be looking at the relationship between some of these terminologies. Some of these terminologies have some relationship. For example, angular velocity and linear velocity, angular acceleration and linear, they have relationship. We have period and frequency, they have relationship. So we're going to be looking at the relationship, and in this particular video, I'm not going to be solving any question here. Questions will be solved on the part 2. So the part 2 will actually comprise of energies. We're going to be looking at the energy of simple harmonic motion and solving all questions on post-UME, JAM, why common questions on simple harmonic motion in the part 2. So this is one of the reasons why I will tell you to follow, so that when the part 2 is out, you're not going to miss it. You'll be notified. If you are watching this from YouTube, please subscribe, and if you are watching for TikTok, follow us and go and watch the full video on YouTube. So let's get started. What is simple harmonic motion now? Okay, so it is very important that you understand that motion in itself is actually the change in the position of a body with time. As a body begins to change its position with time, that's actually what motion is. But simple harmonic motion is a kind of motion. What kind of motion? It is a periodic motion. It is very important to know that a periodic motion. Periodic. Now, what does the term periodic mean? Periodic actually means that it undergoes the same system after a given time. Okay, that might be a long or big term. What I mean is, when a particular body or subject or particle begins to undergo a particular type of motion, a particular type of system continuously without changing, then that thing is said to be periodic. For example, if I begin to wave my hand like this over some time, what I'm doing is just periodic. So a periodic motion is simply a motion that goes through a particular point at a given time. So you will always see a very common one, which is a simple pendulum. If you take a bulb, tie it with a thread and hang it somewhere, then you release it to go to and fro. That's actually a periodic motion. So simple harmonic motion is a type of periodic motion. Okay, so what is it? What is simple harmonic motion? Simple harmonic motion is a periodic motion in a straight line in which the acceleration is usually directed towards a fixed point and is proportional to the displacement. Let's take it a bit. Simple harmonic motion is first point is a periodic motion in a straight line. Second point, a periodic motion in a straight line directed in which the acceleration is directed towards a fixed point, and that same acceleration is proportional to the displacement. I'm not writing that out. I'm not writing this definition out because I don't want it to take time, but just know that definition. Okay, what's the important point you have to take note of in this definition is that number one, simple harmonic motion is a periodic motion. Number two, it occurs in a straight line. Number three, it has an acceleration, and this acceleration is directed towards a fixed point. And number four, the acceleration is proportional to the displacement. Now, let me use a particular example before I even explain before I say what I want to say. Then let's name some examples of simple harmonic motion. Examples are your pendulum bob, your simple pendulum bob. When you have something like this, so it can be displaced to the left. The bob, you just have a thread, tie the bob to it, then you just drag the thread, drag it towards the left and release it to begin to and fro. This is an example of simple harmonic motion. You have your spring, something like this. Okay, let's say this is where it is anchored to. Then something like this. Then you have the mass that is hung to it. So when you take this part of the mass and you drag it down, you release it, you notice that it will be going up, down, up, down. That's an example of simple harmonic. Remember, I said it's periodic. If that thing is undergoing a particular process over time, then we say it is simple harmonic. So simple pendulum bob, your mass, your spring, your mass to spring system. You have your test tube. Yeah. So if I put water, I put sand in my test tube, then I displace my test tube inside water like this. You notice it to be going up and down. That's another one. The beating of the heart, the movement of the clock, because your clock will move 1, 2, 3. It will always pass each of this number at a given time. So any system that goes through this, that undergoes this process, is actually simple harmonic. Now, here's what I want to explain. Because while I was giving you the definition of periodic simple harmonic motion, I mentioned some important things, and it can be confusing because one good thing about physics is understanding. The moment you can understand physics, it actually means that you will be able to solve any question. Understanding actually matters in physics. And let's go. Now, I said something. I said the acceleration of simple harmonic motion is directed towards a fixed point. The question is, what is the fixed point? How is the fixed point? Where can I find a fixed point? And that thing I said again, I said this acceleration is also proportional. Proportional. The word proportional means it varies. It varies with the displacement. So somebody will just student will just cram this definition and go into the example, and at the end of it all, they make mistake. So now let's break this term down. So let's say I have a string. This is a wall. Okay. I want to explain that too. This is a wall. Let me name it. That's a wall. So I have a string. Horizontal string here. Okay, let me label it. Let me just put something like this. We'll show that it's a string. So this is the wall. This is a string or a spring, whatever you want to call it. This is the mass that is attached to the spring, mass on the body. This is the mass. Okay. So the distance between this point to this point is the initial distance. So the point at this stage like this, the mass is stationary, it's not moving. So at this point here, let's label this point here. This point where the mass is, let's call it point X. So the distance between here to here. So since it's not moving, let's call it is just at a fixed point. This is the equilibrium position. So when we are dealing with simple harmonic motion, we are going to be making use of the term equilibrium position. Equilibrium position means the position in which your object is and it has not started moving. That is its balanced point, the point where it is balanced. So it is not moving, there is no force acting on it yet. So this is the equilibrium position. This point where this mass is the equilibrium position. Now let's take note of something. If I take this spring and I pull it towards the right, I apply force Fa towards the right. What do you think will happen? You will notice that the mass will extend a particular distance from the equilibrium position. Let me call it E. Equilibrium position E. The mass will extend a particular distance X. Let's call that distance X. Okay, that distance, that a particular, you can call it Y, I call it X because it is horizontal. If it's something that is dealing with vertical, I'll call it Y. So let's say I apply a force F, apply the force towards the right, and this mass moved through a particular distance x. So you know, we are dealing with displacement here, so I'll also call, you can call it distance and displacement, although distance and displacement are not directly the same, but they are used interchangeably. One is vector, one is scalar. I'll explain that in another video, but let's just understand this one first. So I pull the mass towards the right through a displacement x. If I remove this applied force, what do you think will happen? You will notice that the mass will come back towards, it will be coming back towards this with a particular acceleration, because I have applied a force. Removing the force, the object will run back as if it's coming back with an acceleration. This system, you will notice that the object will come back. It will even pass the equilibrium point. It will pass, go, come, go. It will keep doing this until a point it will now stop at the equilibrium position. Because this system goes to and fro through a particular point at a given time, we say this is a simple harmonic motion. It is periodic. First point. So a periodic motion, a simple harmonic motion is what? Is periodic. Second point, if you look at this, you know that the whole thing is what? Is a straight line. It's not curve. It's a straight line. So a simple harmonic motion occurs in a straight line. So, second point. Third point, the acceleration is moving towards a fixed point. Initially, what was our equilibrium point? This point E, that's our fixed point. So after pulling it and releasing it, when the object was coming towards that, which point was it facing? It was facing the equilibrium point. That's what I was saying. So the acceleration is directed towards a fixed point. So I pulled it this way, release it, it was moving towards the equilibrium point, this point E here. So I pulled it down to this place. Let me call this where I pulled it to. Immediately I removed the applied force, it started coming back to this direction. It was more like a restoring force, pulled it backward. And as it's coming, which point is it facing? It's facing the equilibrium point. That's the fixed point I'm talking about, point 3. Now the last one, which is the point for displacement. This is the displacement, right? Displacement x. We said the acceleration is not only moving towards the fixed point, we also said the acceleration is proportional to the displacement. The word proportional means vary. It's vary. So when you hear the word vary, what does vary mean? Vary means that it means that a particular substance is going in line with another. Let me give you an example. So if I say A is proportional or varies with B, what it means that if B is increasing, it means A too will increase. They might not increase in the same way. It's depending on how they are related. The formula is relating them. They might not be increasing the same way. But if B is increasing, A is increasing. That's what proportional means. It varies with. So as this one is changing, it must change. The effect of this one will always affect this one, and the effect of this one will always affect. That's what I mean by it varies. So this thing varies. So it means that it's not the same. As this one is changing, it will also change. So from the definition now that we have already established, we say the acceleration varies directly with the displacement. How is this possible? So this is what we mean by it varies directly. I hope you know that the farther I drag, or the more force I apply, the farther I drag this mass from its initial position will determine how much acceleration it will use to come back. If I drag this object from here to here, you will notice that the acceleration will be small. If I drag it from here to here, you notice that the acceleration will be small but bigger than the first one. If I drag it from here to here, like the farther I keep pulling the object away from the equilibrium position, the higher the acceleration. And you also notice that the farther I pulled it, the more the displacement. As I'm pulling it, the displacement is increasing. I'm pulling the displacement I'm pulling the displacement. So as I keep pulling it, displacement is increasing. So also, if I release it, it will also determine the acceleration with which it will go back. So this is what we mean by the acceleration is proportional to the displacement. So acceleration is proportional to displacement. Let me use x, displacement x. Are you with me? So acceleration is proportional to displacement. That is what simple harmonic motion is trying to tell. So if I increase x, the farther I displace the object, the more acceleration it will use to come back. Now, if you are a student who has read this topic before, you will notice that anytime they write acceleration, they will always write it this way: a A is equal to minus W squared X. And the student keep wondering, how is it that this negative is there? Although during the course of the video, student keep wondering, if I've been studying this, if I've studied this topic before, you are going to understand. Student keep wondering how A is directly proportional to A is equal to minus W square X. That's not actually W is called omega. We are going to see during the course of the video anyways. Student keep wondering, how come there is a negative sign there? Why is there a negative? And if you look at the definition I gave you, remember I said that simple harmonic motion is periodic on a straight line at a fixed point. I've already explained the fixed point aspect. Then I said it's proportional to the displacement. Now this is one thing you should know. In physics, most time the negative there actually means that most time it does not actually mean the value for that thing, like okay, the value is minus. No, the negative sometimes means that the thing is moving opposite to each other. And this is why you will always see in your equilibrium of forces that resultant force is equal and opposite to the equilibrium force. What does that mean? If the equilibrium force is moving to the right, resultant will be moving to the left. If resultant is moving to the right, equilibrium moving to the left. So the negative there does not necessarily mean that the thing has a negative value. No, the negative there means that it is moving opposite to it, and this is why they always put negative. And we are still going to look at how this formula was got, but I want to explain why you always see negative there. The negative is actually coming from the display, from the definition. The definition said the acceleration is proportional to the displacement, and it's moving opposite. Now let's watch something. Remember that if we pull the object with the force towards the right, what direction is the displacement? Right? Is that not it? Then if you leave it, what direction will be the acceleration? Left. So acceleration is moving to the left, displacement is moving to the right, because both of them are opposites. And also we have also established that the farther the object is away from the equilibrium position, the higher the acceleration it will use to come back. So acceleration is proportional to the displacement and also opposite to the displacement, and that's why the negative sign is coming there. So acceleration, so the best way to write is this: A is directly proportional to minus X. The negative there means that the acceleration is opposite to it. The proportional sign means that it varies with it. It is very, very important to take note of that. So that's just what simple harmonic motion is. So we have been able to do simple harmonic motion. We have been able to get examples of simple harmonic motion. I just gave you periodic, simple pendulum, and some other ones, and this mass to spring system. We have other ones though. So now we want to look at explaining simple harmonic motion in a straight line and in a circular path. Actually, the straight line is what I just explained. It's what I've already just established using the mass to spring system. So this straight line is all this thing I've explained here is just for the straight line. So if we want to now talk about the circular path, let's look at the circular path. It's the circular path now that is actually big. So let's look at the circular path. So now let's say we have a circle, just a circle. It might not be actually accurate, but just bear with me a second. Now, one thing I want you to understand is that anytime I'm talking about simple harmonic, because somebody will be asking or wondering, okay, sir, you said that simple harmonic motion occurs in a straight line. How come we're not dealing with circle? Calm down. Anytime we're dealing with simple harmonic motion in a circular path, our attention is not actually in the circle. There is something more to what we look at, because if you look at textbook will put circle, and some students will look at, they'll be confused. Calm down, I will explain to you. So let's say you remember when we were small, there's this thing we used to do. We'll tie an object with a rope and begin to whirl it around a circle. Like you just be whirling, you just be rolling. Let me use the word rolling, because whirling now will be making some people thinking like that. Let me just use the word rolling. Be rolling this way, exactly. It's from a circle. So let's imagine it was a stone you were doing like that. So let's call that stone P. So let's say the stone P is somewhere here when you were rolling it. Remember, as I rolling it, it's moving fast, so it's not slow. I only decide. No, see, when we are talking about physics is physical. If you are able to bring physics into the normal world, then you have no issue. So it's you being able to reason physics and bring it into the real life system. That's what physics actually is. So remember, you are rolling the stone. It's not slow. It's moving fast. So the thing is going very, very fast. But I just decided to like pause it and say, let's imagine this is where the stone is. Okay. So let's also remember that this is the center of the circle where you are rolling the stone. Let's call the center. You know what we said? The point where the object is initially, that's equilibrium position. Let's call it E, the center of the circle. So we already established also that when a line that moves in mathematics, a line from the center to any point of the circle is called radius. So this is radius. Sorry that the line is not straight. This is also radius. Okay, so let's imagine that we have some underline there. So this is also radius, because as long as the line is moving from the center of the circle to any point of the circle, it is a radius. Don't mind the fact that this my semicircle here is smaller than this one. I just want to establish something. So also imagine that you have a ray of light coming from this way. You might not actually imagine, if you want to imagine, but just see a ray of light coming from this way. And from physics, you know that when a ray of light is cast on an opaque object, what happens? A shadow is formed. So P's shadow will be directed downward. Good. So I have P's shadow here. Let's call the shadow Q. So let's call this end here Z. Let's call this place Y. Let's call this place A. Let's call this place B. Now you will notice something, and let's call this center point C, or the equilibrium position. You will notice something as stone P moves like this. As it moves, what will you notice? You know that stone Q will be coming towards this side. If stone P reaches this point A, where will stone Q be? Good, at the center. If stone P reaches this point, well, where will shadow Q? Sorry, no, Q is the shadow of P. Where will shadow Q be? If stone P is here, shadow Q will be somewhere here. If stone P reaches this point Y, where will the shadow Q be? At this Y here. Similarly, if stone P gets to B, shadow Q will be at this point C. If stone P gets to this shadow Q will be here, and if stone P gets to this Z, shadow Q. So as stone P moves around the circle, what happens to its shadow? Its shadows move to and fro in this straight line. Is that not periodic? Good. Is that not simple harmonic motion? Good. So this is why I would say simple. This is why I would call it simple harmonic motion. Because when you are dealing with simple harmonic motion in this kind of a circle like this, we are actually not looking at the object moving. We're not looking at the circle here. What we are looking at is the formation of its image along the center part. So shadow Q moves from point Y back to point Z at every given time, and this is why we call it simple harmonic motion. So it is periodic because it is going at every given time. It is in a straight line, and you also notice that it has acceleration. How do we know that acceleration? Remember I said you are rolling the stone, so the stone P is moving fast. So as stone P is moving fast, shadow Q will not be moving slow, it will be moving fast. So because it's also moving fast, it has acceleration. And anything that makes it to have acceleration, it definitely has velocity, because we know acceleration is the rate of change of velocity. So velocity produces acceleration. So that's what we're trying to say here, that simple harmonic motion in a circular path. But beyond that, there are some things I want to bring out here for us. So look at this now. There's no way you will tell me that as stone P moves, right, moves round, it will move through an angle. It's just like a wall clock. As a wall clock is moving, it's moving through an angle. Okay, let me even use this mathematical example. Those of us who did mathematics, since you're a physics student, definitely you do mathematics in your secondary school. There's something known as angle of elevation and angle of depression. You know, angle of elevation and depression are measured from the line of action of your sight, your horizontal sight. So if you look up, elevate, the angle your eyes make with that potential line there is the angle of elevation. Then if you look down, angle of depression. That there's a potential line of axis, right, which does not change. So it is from that point we use as a reference to measure the angle above and the angle below. Exactly. So as stone P moves around the circle, it creates an angle. It's always having an angle. So the angle will be moving from theta, you know, like that, down. So let's call that angle theta here. So that's the angle. So if you look at your textbook and you see something like this and you have something like they put theta here, we are wondering how come theta appears there. No, theta does not. It's just a normal logic thing that as stone P is moving, it's creating an angle because it's moving around the circle. Good. So if I then decide to bring everything here out, I decide to bring it out here, you will notice I will have something like this. Right, so here will be Q, here will be C. Okay, this is, we'll call this place A, amplitude. That's our amplitude. Here will be A. Oh, I didn't even say this. Now take note, we said the acceleration is directly proportional to the displacement, right? So if this was where stone P started off from, and stone P, shadow Q started off from rather. If stone P was initially here, its shadow Q was here. So as stone P begins to move, you notice that shadow Q is moving to and fro. So our focus, our key focus is just here. So this was where shadow Q started from, but this is where shadow Q is. It means that shadow Q has displaced a particular distance x. It has displaced, look at this, from here to here, that's the displacement x. So this is it here, x. So x is actually the displacement of shadow Q from point C, or from the center to this place, which is the equilibrium position. So all of these things, I brought it out here, and this is our theta. Now in mathematics also, there's something known as SOHCAHTOA. So I don't know if you were taught, the scholars here will know SOHCAHTOA, right? This SOHCAHTOA is actually used to solve questions on angles. So let's see what can work here is, because I want to represent x, theta and a in one equation. So the angle that will help me is this K means cos theta. Okay, now this is it. In a right angle triangle, the longest side is the hypotenuse. The side facing the theta or facing the angle is the opposite, while the other side is called the adjacent. So since this is opposite, this is adjacent, this is hypotenuse, then we have cos theta is equal to adjacent over hypotenuse. If I cross multiply, I will have x is equal to a cos theta. Please take note of that formula. That's the first formula we have to then take note. These are the codes. So if you see anywhere in any past question or textbook and you see x equals a cos, these are they got it from this whole stuff. So that's the first one. Let me just call that one formula 1. We'll be needing it in the future. Take note of formula 1. X equals a cos theta. So this is how we are able to explain simple harmonic motion in a straight line and in a circular path. So the straight line, just to recap, the straight line is actually the one I use is mass to spring, that I say if you push further and the rest, while the circular part is this one here. So this is just what it means. So if you are asked, or if you are to say it in a simple term, what does it mean that there is simple harmonic motion in a circular? It's just that our key focus is not actually in how it moves in circle. It is the image produced by the object in that horizontal part of the circle. So this is what we are trying to say. So like I said, I prove it to you that this is actually simple harmonic motion because the image moves to and fro, and that's periodic, and the line is straight. It's the image of that object is actually directed towards the center or directed towards a fixed point. That's also correct. I would say since the real object is moving in a circle, it will have acceleration, and the acceleration is actually proportional to the displacement and is opposite to it. So all of these things prove that simple harmonic motion is actually in a straight line and also in a circular path. Now the next thing we want to look at is the terminologies of simple harmonic motion. And the earlier part of this video, I made us understand that you cannot understand or solve questions on simple harmonic motion if you are not conversant with the terminologies. The terminologies are actually formulas, and based on my years of experience on teaching students, I've come to realize that many students are lazy in learning formula. Some persons were asking that, sir, is there not a way we can just do that? See, formula is formula. Just like they tell you, A is this, B is this. Formula is formula. What you have to do is you don't cram formula, you master formula. And how do you do this? You solve questions using that formula. And that's how I got to learn formulas while I was still in preparing for JAMB and post-JAMB. So I learned the formula by getting myself conversant with questions. So if I look at a particular topic like this, I'll go and solve so many questions. After I've learned all the formula, I go and solve them. As I fail it, I go back, check the formula, use it to solve. I keep solving, and that was how it stayed. But if you cram it and enter the exam, you might mix them because they are much. So let's just get straight to what we have, terminologies. So when we say terminologies, what is terminology? Terminologies actually talks about the terms you use to solve questions on a particular topic or a particular stuff like that. So when I say terminologies of simple harmonic motion, I mean those things you have to know in order for you to solve question on simple harmonic motion. So let's go terms of SHM. So the first terminology we'll be looking at here is the amplitude. Amplitude, you can see it. Amplitude. We're going to be looking at the amplitude first. So let's go. What is amplitude? I want to explain some things here, and I want to beg you that you listen attentively, because I'll be differentiating amplitude from displacement, because most times they always look the same, and there's a way question is to coin something. So like I said, the emphasis of this part 1 of this video is to expose the secret to you. Then part 2 will now solve questions and touch other part that we could not touch in part 1. Okay, what is amplitude? Amplitude is simply the maximum displacement by the object. Maximum displacement of the object is amplitude. So anytime you hear amplitude, just know that they are talking about the maximum displacement. So if a question tells you that an object undergoing simple harmonic motion displaces 5 centimeters, is that the amplitude? No. Until you finish reading the question, don't just say, unless the question says an object have a maximum displacement of, just that once it have a maximum displacement, that's the amplitude. Now, what does the term maximum displacement mean? Maximum displacement means that the highest displacement it can ever have. So let me give you a scenario. So this is the equilibrium point C, which is the center. This is beyond this place, there is no other movement, right? If the object displaces from here to here, that is just, let me call this place B. This is just ordinary displacement. That is not maximum displacement. Are you seeing that? But if the object moves from this point C down to this place, let me call this place D, from this point C down to this place, that's the maximum displacement. So the difference between displacement and maximum displacement is that displacement is just its movement from its, actually it's displacement though. Actually both of them is movement from the initial position. But amplitude then means that it is the longest one, the highest movement you can ever get, the highest displacement you can ever get. That's for that particular motion. So that's amplitude. Please take note and be able to get it. So interpret. See, your ability to interpret physics question gives you an edge in solving it. A particle is displaced 3 centimeters. Because sometimes this is where student gets confused, because sometimes the question comes like this: a particle undergoing periodic motion or a particle undergoing simple harmonic motion displaces 3 centimeters. If its maximum displacement is 5 centimeters, student now gets confused. Displaces 3 centimeters. Maximum displacement. What is it? They now get confused. Don't be confused. Let's say it displaces 3 centimeters, that it moves from here to here. Then it has maximum displacement of 5 centimeters, that moves from here to here. So from this understanding, you will be able to pinpoint. If they say an object has a displacement of 3 and 5, you know that 5 will be the maximum displacement. I'm just giving an illustration here, so please take note. So you can have a question that has both amplitude in it and also have displacement in it, and you will need the two of them to solve that particular question. For example, I don't want to jump, but let me just say this. Look at velocity. The part that will say find the velocity. The formula for velocity is V equals omega root a square minus s square. If you look at this particular thing, A is displacement, X is displacement. A is maximum displacement, X is ordinary displacement. You can see some question will give you A and X and say find the velocity. I'm going to explain when we get there too. But what I'm trying to explain to you that amplitude is the maximum, is always bigger than the original displacement. And there are also some cases where this and this are equal. When this and this are equal, then you just say it has a maximum displacement of this. That's all. So let's take note, please. Very, very important. Very, very important. Take note of it too. Amplitude, maximum displacement you can have. Then the next one, number 2 terminologies, is period. So let's look at that. Period. So now, many a time students confuse this with frequency, but I'm going to be differentiating it now. What is period? Anytime you hear the word period, remember time. Period, time, period, time, period, time. So what is period? Period is the time taken to complete one cycle. Period is the time taken to go through and fro. That's period. So remember we're talking about simple harmonic motion. Simple harmonic motion, it will actually call it simple harmonic motion because it is periodic, and we call it periodic because it has undergone a circle. So if it starts from here to here, so if you move from here to here,
it is not periodic yet. So if it move from here to here and back to here, that's when it is not periodic, because it has undergone one cycle. So from here to here and back is one cycle. So the time taken for the object to move from point A to point B and back to point A is what we call period. So you can say time taken to complete one cycle. Take notes, please. Very, very important. It is represented with T, capital letter T, and the formula for it is T over N. This small t is the time, this n is the cycle, n over n. Let's take note. So that's the period. So if they also give that, an object undergo 4 cycles in 2 seconds, what is the period? It's simply 2 over 4. 2 here, 1, 2 here, 4, 2. That's 0.5 seconds. So that's the period. That's how to find period. Number 3, we have frequency. What is frequency? Frequency is the brother of period. They are inverse, but I will get there. Frequency is simply the number of cycles completed in 1 second. So number of cycles. So this one is time taken, period, time taken. Frequency, number of cycles. So number of cycles completed in 1 second. So F is equal to N over T. Did you see it now? So they say an object completes 10 cycles in 4 seconds. What is the frequency? That's 10 over 4. That's 5 over 2. That's 2.5. The unit is hertz. Take note. Or per second. These are important things you need to. So many of you know frequency as hertz, as Hertz. You know it as hertz, but you don't know it as per second. Take notes. X minus 1. Now, why is it called per second? We're going to understand. So if you look at the last part of this objective, I say the relationship between some terminology. So period and frequency has some relation. So I'm just going straight to the point. The relationship between period and frequency is that they are inverse to each other. So period T is inverse to frequency, or frequency F is inverse to period. Any of them. So because if I cross multiply, I'll still get the same thing now. So this is where we get the part. So since the unit of period is second, so 1 over seconds, indices S square minus 1. That's how we call the per second. So remember this: frequency, amplitude, period, frequency. I want to beg you to take note of this. Take note, because when we start in the part 2 video, when we start solving questions, I would believe you already know these things. So I'll just be solving questions and just be bringing the formula in. So period, frequency. So number 4. Let's look at number 4. We're looking at, let's look at angular velocity. Angular velocity. This one is represented with omega. We call it omega, O-M-E-G-A. So angular velocity is given by theta over t. Somebody will now be confused that, how is it? Do you remember when we were dealing with simple harmonic motion in a circle? Remember, I said something. I said the angle moves through theta. Like as the object stone P is moving, it's sweeping through an angle theta. And anytime we are dealing with motion, obviously we cannot talk about motion without talking about time, because time will not be still for motion to be going on. As long as motion is going on, time is also going. Time, have you had time wait for no man? So as I'm moving, time will not say, let me wait to let Tutor Glycol move. No, time will not say, let me wait to let the stone sweep through. As the angle is being swept through, time is going. So time is changing, obviously. So angular velocity is the rate of change of this angle, the rate at which this angle is being swept over. Enter here the word rate just means over time. It's divided by time. So this is why here acceleration is the rate of change of velocity. Then if you find a formula for acceleration, you have V over T. Anything you hear the word rate in it, always know that it is divided by time. So angular velocity, we call angular because it's dealing with angle. Angular velocity. We included velocity because it's talking about the speed with which the angle is swept through. You get angular velocity. So theta over to rate of change of the angle. So this is the formula. Then We now have the next one, angular acceleration, number 5. These are important terminologies, take note of. Angular acceleration. I will rub off the one at the top, this part. If you are writing, you should have been done with that. So angular acceleration is represented with this sign. Yeah. So angular acceleration, so just like the way angular acceleration is the rate of change of angular velocity. So angular acceleration is what? Omega over t. Let's not forget the unit for this. The unit for the angle here is radian. The angle is measured in radian, not in degree. It's in radian because we are dealing with values, numbers. So it's measured in radian. The time is second. So unit of angular velocity is what? Radian per second. You always see this in your post-semi, in your jam, whatever, radian per second. Take note of unit. Very, very important. Physics, without unit, you don't know physics. Take note, radian per second. So angular acceleration is what? Radian per second square. Don't forget the unit to radian per second square. Don't forget the unit. So far, so good. I've been able to get 5 terminologies. I'll be rubbing the first 3 so that we can put the other terminologies there. So don't forget amplitude, maximum displacement, how much, how far, period, time taken to complete one circle, frequency, number of circles completed in 1 second, relationship between period and frequency. I showed us 1 over f, 1 over t, angular velocity, rate at which the angle is being swept, angular acceleration, rate at which the angular velocity. Good. So let's now look at the remaining one, then check other stuffs. Okay. Number 6, that's linear velocity. You can see I separated them. I didn't just write velocity, linear velocity. This is the one you know, v. So obviously you know that v is equal to what? Distance, s, time. Right? You know this now, so don't forget. Then we have linear acceleration, number 7. Acceleration A. This one is the unit meter per second. This one is A equals V over T. This is meter per second squared, the unit. Don't forget it. So this one is something we are common with, so we'll not really waste time there. So now there's a relationship between linear velocity and angular velocity. Yeah, relationship between linear velocity. Let me put this way: relationship REL, relationship between angular velocity and linear velocity. So what is the relationship? V is equal to angular velocity times radius. How did this come about? But just know this for me. How did this come about? Let's get how it came about. V is equal to WR. So if you notice, I want to rub up this part so that if you notice, remember we said something. We said that W is equal to theta over T, right? Then from circular what do you call this, from mathematics, if you are looking for circumference and all the rest, we notice that theta is equal to S over R. How? If we have a circle here and we have a small arc, something like this is the arc here, arc S, this is angle theta, and this is the radius. Okay, so if we are to solve now, we say theta, the angle theta is equal to distance, the arc over the radius. That's when you are looking for, that's not I did mathematics, but I'm trying to remember this perimeter of a circle, circumference of a circle, all those things. So that's where they got this thing. Theta is equal to S over R. So if I'm to relate this and this, let me call this equation 1. I don't know if you get this, but you can visit your mathematics again. That's how they got this. If they ask you to find the perimeter of a circle, you have theta over 360 times 2 pi r, area of a circle, all those sector. Yes, that's the word. Yes, sector of a circle. Yeah. So when you're dealing with sector of a circle, you can go and check it out. The theta is equal to S over r. This is how they got it. So since we are talking about, we said that we can relate our simple harmonic motion into a circular path. I've said all of that before. So from there we get this formula. If I call this one equation 1, I call this one equation 2. You know that there's what we call simultaneous equation in mathematics, where you solve two equations together by looking at what is here and what is here. So from this equation 1, if I make theta subject to the formula, look at from equation 1, I made theta subject to the formula. I will cross multiply. What will I have? Theta is equal to WT. Is that not it? Yeah, the W is the omega. Let me call this new equation equation 3. I'm using substitution or simultaneous equation now. Now, if I then put this equation 3 inside my equation 2, what does it mean? Anywhere I see theta in equation 2, I will put my equation 3 there. Anywhere I see theta there, this theta equal WT means that, anywhere theta is, it is WT. So I'll just substitute this whole thing here into this. Then I'll have WT is equal to S over R, right? So divide both sides by T. Now what I want to do, now let me not go too much. What I want to do is that I want to solve in such a way that this R and W will stay one place, this S and T will stay one place. So what will I do? Divide both sides by T and multiply both sides by R. Is mathematics. Although in your post-UTME, in your JAMB, your WAEC, nobody will ask you to derive this. What they just want is that you know the formula, the important formula I've stated. That's what they want. So this one is an important formula you should know. Just know this one. What I'm trying to do is I'm trying to show to you how this thing, because it's in your textbook, you'll be looking at the textbook and you're wondering how did they get it. That's what I'm just trying to show to you, how they got it, how they got this thing. So it's not really difficult. So I want to make W and R stay one side, S and T one side. So I'll just divide both sides by T, multiply both sides by R. Then I will have WR is equal to S over T. Do you remember that S is representing distance moved, right? So distance over time is what? Velocity. Good. So I will have WR is equal to velocity, V is equal to WR. Is that what we have here? V is equal to WR. So it's just how this how they derived and they got this stuff here. So that's the relationship between omega, that's angular velocity, and linear velocity. So if you are asked what is the relationship between angular velocity and linear velocity, this is it here. So you now see a question that, oh, they give you a question, they gave you the angular velocity, they gave you the radius, they now say find the linear velocity. This is the formula you have to use. If they give you a period, they say, okay, an object undergoing superharmonic motion move or have a period of 2 seconds. What is the frequency? There's a relationship between period and frequency. What is it? Period is equal to what? 1 over frequency. Or frequency is equal to what? 1 over period. This physics is actually not difficult. It's not actually not difficult. Just know how to release it, know how to bring it to real life. Okay, let's quickly look at the last relationship, which is linear acceleration and angular acceleration. Very quickly, relationship between linear acceleration and angular acceleration. I'll write that again. Relationship between I think my marker ink. Relationship between linear acceleration A and angular acceleration. These are the represent angular acceleration. So what's the relationship? Let's go again. Remember our acceleration A, linear acceleration is what? Velocity, linear velocity over time. And also remember that angular velocity is what? Angular acceleration is angular velocity. Let me do this very well. Over time. I hope you know something is similar to them. Okay. If you reconsider, this whole thing is not cramming. I don't usually advise my students to cram. Never. I have never advised them to cram. What I tell them is understand the concept. Just understand how the thing is. See, when you get to the exam, you can even derive the equation yourself. Like, you can only know one equation, and from that one equation, you can derive every other one. You don't need to start cramming. If you cram, you have too much formulas on your head, and you will start to exchange them. If you notice that I've been solving these things since I've not even started. Although I know them, I can just start writing them out. I'm without looking, and I'm writing them out. Not because I'm a beast or anything or whatever you want to think. It's just that I have come to realize that physics is not abstract. Physics is practical, physical. That's what the physics, the spelling physics was go for physical. It's something you should bring to a reality. Bring it to reality. Bring it from that your theoretical brain. Bring it to reality, and you are good to go. Don't worry, we will be here together. There are so many topics I'm going to demystify for you, and you will come to realize that physics is actually not something I should be bothered about. So let's look at this now. From our last relationship, we know V is equal to angular velocity times radius. Is that not it? So if I put anywhere, remember the substitution, anywhere I have V, it is WR. I have V here, so I can replace it with this whole thing here. Is that not it? Just put it here. I'll have A is equal to WR over T. It's the same thing. It's just that it depends on what the question. So this to bring to your notice that there are sometimes the question will give you W, give you R, and give you time, and say find the linear acceleration. They will not give velocity and time. There are some students will now say, I know this is the one I know. Why are they giving me this? You now say it is incorrect. No, bro, it is correct. It's actually correct. It's you that do not know that there is something like this. This is why you have to, you're on that. This is why many people enter the exam hall and they come out failing. They'll be like, I read this topic, why come am I failing? It's because you there are keys to this thing, there are ways to these things which you should know. There are other dimensions. See, the question now I want to know if you truly understand it. So they will twist it, and you will come to the exam hall and you're like, oh, I know this thing. How come I'm not? This thing is trained angular velocity, radius, time. How can I find it? You can actually, if you calm down and dissolve it. So let's go. We are looking for the relation between this and this. So I have A here, WR over T. You know how I got this, and I have W equals this and this. From here, if I make from this place here, if I make W subject to the formula, if I make it subject to the formula, I'll have W is equals angular acceleration times time. I've made that, right? So another substitution again, I'll now substitute this whole thing inside this place. Why am I doing this substitution? I'm doing this because I want to look for a relationship between A and this. If I don't want to look for a relationship between, I will not do all of this stress. It's because I want to look for it. So I'm looking for a way I can bring this and this into one equation. That's why I'm keep substituting. Now after substituting this into this, you will now notice that A and this has now entered one equation. So I'll be having something like linear acceleration is equal to W. I will not write W again. I rather, it's not called W, it's omega, but I'm just using it because it looks like W so that it will be easier for you to get. So W is equal to these two things times T. Remember I have my radius there, times radius over T. T will cancel T, is that not it? T will cancel T. So I will have acceleration is equal to this time. So what does it tell you? Linear acceleration is equal to angular acceleration times radius. Now just to make you know something, what do we have here? V is equal to, from what we got that time. You can see the relationship. So you can see that they are almost similar. You don't need to cram. Look at linear velocity is equal to angular velocity times radius. Linear acceleration is equal to angular acceleration times radius. Anything different? So anytime you remember velocity, if you can remember this, then you know that the acceleration on is almost the same type. It's just for me to put acceleration. So if I want to get this one, all I have to do is clean V, put linear acceleration, clean angular velocity, and put angular acceleration. They are similar. So if they give you a question that you should find, they give you angular acceleration, give you radius, and say find a linear acceleration. Don't say there is no formula. There's actually a formula. So guys, these are the most important things that you should know. I hope that I've been able to help you understand. This is just the part one. We're not done with simple harmonic motion because I've not treated energy, talk about some other, look at simple pendulum properly. Okay, and I've not even talked about velocity. And let me quickly look at that. Okay, let me quickly look at that very fast. Although I not put it here, but let me look at it. Okay. So what I want to look at here is velocity and acceleration of simple harmonic motion. Velocity and acceleration of simple harmonic motion. So let's deal with that quickly. Velocity and acceleration of SHF. So simple harmonic motion, we already saw that it has acceleration, and if it has acceleration, definitely it has velocity. Now the important thing you have to take note of, we say it's in a straight line, right? Simple harmonic motion occurs in a straight line, so I'm going to be using a straight line to explain this. So let's call this place center, the equilibrium point. Let's call it equilibrium point. That's where the motion actually started from, E. So that's the equilibrium point. So then I'll call this point A, I'll call this point B. Okay, so as it moves to and fro simple harmonic motion, please take note that when the object moves from here to here, let's call this point C. Let's call this point D, let's call this point C. When the object moves from point C to point D, this is just displacement, that's just displacement X. But when the object moves from point C to point B, that's what? Amplitude. Let's take note, very, very important. So the velocity of simple harmonic motion is given by V is equal to omega root A square minus S square. This formula is the derivation of this formula. You actually do not need it, but it's actually gotten from that right angle triangle stuff, something like this. You don't really need the sha. Yeah, I said this is from that circular stuff now, A x theta. So if I call this place pi, so using Pythagoras theorem, we have y square is equal to a square minus s square. So this is where they got this thing from. If you understand. So just putting one or two things together. You don't need the derivation for that one. All you have to know is that this is the formula for finding the velocity. Now this is where I'm driving to. This is where question comes up. Nobody will ask you derivation. Tricky question will just come. This is where they will ask you, find the minimum velocity, find the maximum velocity. This is where my attention is. What do we mean by minimum velocity? The word minimum means the least, the word maximum means high. Minimum velocity means what is the smallest velocity it can have, and at what point will it have it. What is the maximum velocity it can have, and at what point will it have it. In simple harmonic motion, the velocity is maximum when it is coming towards the center. Please don't forget that. When the object is coming towards the center, the velocity is increasing. So if it's here, as it's moving towards the center, it will be increasing. Once it passes the center, it will be reducing. So velocity is maximum at the center, but minimum at the extreme. That's a key point. Velocity is max at center and minimum at extreme. Don't forget this, please. Don't forget this, please. Velocity is maximum. Let it stick to your brain. Velocity is maximum at the center and minimum at the extreme. Now, how do we prove this? Let's prove how tricky. Remember, this is the formula we have said. So I'll just pick three different things. So let's say the first point, I'll pick 3 points. This is, so let me pick 3 points between this C and B. This is first point, this is second point, this is third point, and that's the maximum one. At each point, right, the displacement is 2. Let me use 1, 3, 5. These are the displacements. So the first point, x1 is 1, x2 is 3. These are different points. I want to prove these things for you. Okay, so let's take the amplitude. Let's take the amplitude as 5 as the maximum anyways. So let's go. Okay, this is where it started from, right? This is initial, so this is 0. Because imagine if I'm starting from here, I've not started moving, so my displacement is 0. So from that's 4 points now. 0.1, 0.2, 0.3, 0.4. So at the beginning, this is center. This displacement is 0 at the center. At this first point, the displacement is 1. At this second point, the displacement is 3. At this third point, the displacement is 5. So let's impute it into this. This is the formula for velocity, right? Let's impute it. This W here is a constant. I'll not give. Okay, let me give it a value. Let's say I'm trying to prove to you that velocity is maximum at the center and minimum at the extreme. Let's say velocity, this W here, let's say it's 3 radians per second. So let's go, let's solve. So V1, first one, this V1, V2, V3, V4. So V1 is equal to, what is our W? 3 root, what is A is 5 square minus, what is X? 0 square, because the first point where we have our X is at the center point. that's 0. So that v1 is equal to 3 into bracket 5 squared is 25. 25 minus 0 is still 25. Root 25 is 5. So 3 times 5 is 15. So our first v1 at the center is 15. Let's do for v2. That's 1. So this will be 25, right? 1 squared. That's 1. 25 minus 1. 25 minus 1 is 24. Root 24 will give you a number less than 5. Because if root 25 is giving us 5, root 24 will give us a number less than 5. I'm not with my calculator here, but that should be around 4 point something. So 4 point something times 3, it will still not be up to 15. I hope you know. So it's less than 15. So let's just give it 13 point something. Please don't get confused. You can use your calculator to press and confirm this. So V2 will be 13 point something. Okay. Now let's go to V3. V3 is this is 3, right? Good. So using this formula, our A is 5. 5 squared is 25. Our x here now is 3, because we did for the first one, this for the second, now we're doing for the third one. Our x is 3. 3 squared is 9. 25 minus 9, I think that's 16. Root 16 is 4. 4 times 3, 12. So which means our V3 is what? Is 12. 13, 15. And let's go to the last one. 5. 5 squared, 25. 5 squared, 20. 25 minus 25 is 0. Root 0, 0. 0 times 3, 0. V4, 0. Among this one, which one has the lowest value? V4. Where is V4? Extreme. Among this one, which one has the highest value? 15. That's V1. Where is V1? Center. Velocity is maximum at center, but minimum at extreme. I hope that makes sense. Please, let's take it. Very, very important. So that is for velocity. This is velocity for simple harmonic motion. This is the formula. So to go straight to the point, because we know that velocity is maximum at the center and minimum at the extreme. If they ask you what is the maximum velocity, all you have to do is simply say V max. Instead of all this long, you just say V max is equal to W times A, because at the maximum point A and this is the same. As just sorry. At the maximum point, it's at the center, because at the maximum point there is no displacement, so x is 0. So just use this formula for finding maximum velocity, because at the maximum velocity is only gotten at the center, and at the center x is 0. So anything, so 0 raised per this thing will still give you 0. So you just cancel that. So if they ask you, if you see jam, because jam is an exam, is an exam with time. Post-term is an exam with time. WAEC, they can ask you to solve sharp, but jam and WAEC, that is only OBJ and exam with time. If they ask what is maximum, stop going all this long to just say V max is W times. It just multiply angular velocity times the amplitude. You are good to go. Remember that they might not always call it amplitude. They can call it maximum displacement. Just do your stuff and go. But if they say what is the minimum velocity, that's where you have to include something, because minimum velocity is always beyond the center. So it can be here, can be here, can be here. Do you understand? So that's for velocity. Now for acceleration. Like I said, you don't need the derivation. Acceleration, the way they derive acceleration is from differentiation mathematics, and I don't think everybody here watching this video know differentiation, but that's how they got it. And how did they got it? From that illustration I gave, that first formula I gave, like I said x is equal to a cos theta, right? Then that's the first formula I gave you, and I said you should take note of it. So you know, remember theta is WT. I also said something like this. If you watch the video and pay attention, you remember a point I said W is equal to theta over T. So if you cross multiply, theta is equal to WT. So I can substitute this. I will have x is equal to a cos WT. So if you differentiate this, you have the x dt is equals to AW, or is it WA, anyone, WA sine WT. The cos will give, is it negative? Yeah. So this is dx dt. Dx dt is velocity. Then if you now differentiate the second time again, so dx dt, you don't actually need the derivation, shall. It's just the final answer. It's just I'm just showing you how they arrive at this thing. So dx dt. So this dx dt means the rate of change of displacement, and rate of change of displacement is velocity. So it simply means velocity is equal to minus WA sine WT. If you now differentiate this one again, you have dV dt will give you minus W squared A cos W. Somebody's already confused. Where is this is differentiation? And I know I'm not explaining differentiation in this video. You don't need the derivation. I'm just showing you how they just got it. So at theta equals 0, because 0 will give you 1. So you just have A is equal to minus W square A. What do you need, bro? What do you need, sis? What do you need, my friend? What you need is this one. What is it? Let me write it very well. This is what you need. Acceleration for simple harmonic motion, A is equals to minus omega square times the amplitude. This is what you need. You don't need all this one different. You just know this one. That's what you need. Remember, I also said that the minus here does not mean A is negative. What does it mean? It means that it is opposite to the displacement. It does not really mean that the A itself is negative. Very, very important you take note of this. So I know what I'm saying. Take note of this. So this is it, okay? So to just wrap it up, the video is actually part 1 and part 2. This is part 1. Part 1. Forget part 1. So we have looked at what is SHM. You can go back to review it. Examples, explaining SHM in a straight line and in a circular path, terminologies of SHM, amplitude, period, frequency, angular velocity, all of these terminologies. I've explained them. I've also talked about the relationship between something. I also talked about some terminologies and how they were gotten and the ones you need to know, and I also did that. So the part 2 will be what we'll be looking at majorly is some of those potential examples that question comes out from, energy and solving question entirely on everything. Then I will help you explain, because there are some theoretical questions that come from forced vibration, damped vibration, resonance, all of these small theoretical questions. I will touch them in the part 2. Make sure if you watch the video to this point, make sure you follow me, Tutor Glycol, on YouTube, Instagram, and on TikTok. Okay. If you are watching this video also on TikTok, maybe a part of it will not be complete on TikTok because of the length. You can go and watch the full video part 1 and part 2 on our YouTube platform, okay? And don't forget, if you're a JAMB student, post-term student, maybe you want to prepare for JAMB 2027, or you're writing post-term this and you're seeing this video, message me. I'm currently doing a physics and chemistry combo class for post-term student. And if you're a JAMB student who is preparing for 2027, make sure you also message me, because we have a group for JAMB students where we groom them, teach them over the years. We have taught students and they have entered several schools, their choice, medicine, your own should not be a different. Please don't forget to share this video, share it please, and follow me, so that subscribe to our YouTube channel so that when this part 2 drop, you'll be notified. All right guys, take care. Thanks for having me. I did not even put my number. You can check my number on the screen, or you can simply just get it here, 070 36 59 30 57. That's for those of you who want to message me and get in touch to other things, and for JAMB registration and everything. Okay, so you can just call me Tutor Glycol. I hope you enjoyed the video. I hope you learned. So just drop your comments, drop your questions on the comment section, or drop whatever you are not really understanding on the comment section. And you can also drop the topic you want me to look at next. Okay, see you guys next time.